Alright, time for another DraftPhysics.com video presentation. So I made a video last night responding to a Leksa video. And probably it's one of those cases where I shouldn't have cold watched a video. And, but, I was sort of confident that he wasn't going to be able to turn this to their advantage, frankly. And I'm still very confident of that, but yes, I said the middle of the video I said something backwards, and it just isn't right. So I have delisted that video. I haven't deleted it, but it's not listed video. But I was just wrong, and so after 30 views or so, I realized my error. And so I'll fix all of that first. So I just kind of redo the video. Alright, so we're back to, so before I play the video, I'm not going to play the whole video because frankly there's only certain parts of it that are relevant, because most of it is just going to be another version of me saying this part, which we agree on. Frankly, the part where this is the experiment. Alright, so there is a video of a 1 mass hitting a 3 mass. Okay. Newton's cradle. And I'm arguing that this can't do what their math says it should do, blah, blah, blah. It's impossible, blah, blah, blah. So anyway, so the idea is you give this velocity, okay, and we're going to say it's just 100 for the sake of argument, that's how much momentum we give the small object. It hits the 3 times the mass object, and their theory says this goes off with 150 momentum, and this returns with 50 momentum. Okay, increasing the momentum of the system from 100 to 200. Okay, so now you have 200 in momentum. So now you have a 3 mass, and now you have a 1 mass. So this one has 50, and this one has 150 momentums coming back. And that's the real problem, and that's the problem he evaded. So he had emailed me before he made this video, telling me about this video, and I pointed out it's in one of my 5-minute videos. And, and I told him that this is the real part that's going to be impossible to explain, is how you can have 150 worth of momentum now in the system, because it doesn't go away, unlike the cart. So unlike when you're banging a cart into another cart, the carts just take off, and that's the end of the experiment. This doesn't have an end of the experiment. Now you have to account for this extra momentum you created. So this 150 hitting 50 has to be conserved. I mean, every Newton's cradle experiment I've ever seen always conserves the momentum. They don't subtract. So it's like you can't hit a ball with a 50 momentum, let's say, into a ball with a 49 momentum, coming the other way, and have any prospect that it just one momentum pops out, that they subtract, that somehow this vector crap could mean anything. There's no vector part to Newton's cradle, so they don't care about no vectors. So whatever goes in has to come bouncing back out again. And in the real experiment, the fact is they come back together, alright, and the only thing that happens is the little ball goes off with 100. 99, almost 100% of the original. We'll just say 98% of the original energy, the original momentum. So even though it's 150 to 50, even though it's 200 momentums crashing, only 100 comes out. So you destroy the momentum somehow. So you create free momentum, and then you destroy the momentum. No evidence that Newton's cradles can do that. Nothing I've ever seen indicates that it comes anywhere close to doing this 150 against 50 equals 100 thing. Doesn't happen. If I set up an experiment to crash 150 into 50, I'm going to have to conserve the momentum. So there's no chance what he's saying, okay, what he's saying is that these velocities are correct. So based on regular physics, okay, Newton's physics, you'd argue that 75% of the momentum goes this way and 25% of the momentum goes this way. And that means that the velocity has to be 1/4. Okay, for both of these, 1/4 of the original velocity, and their prediction is 1/2. Okay, and he's saying that by using the frame rates, he can see this 1/2. And I'm going to argue you can't see that. Now, I argued that you had to go back 3/4 of the distance, and that was just wrong because it only has half the velocity, right? Half the velocity means you're only going to go 1/4 of the distance if you're going up against gravity. So it's back to this thing. You're going up against gravity. And so half the velocity gets you this. Okay, it doesn't get you 3/4 of the distance. Half the velocity only gets you 1 unit of distance against the gravity. Each unit is the same force you're fighting. And, half the velocity just isn't very powerful. Okay, I mean, you drop it from this distance, you get half the velocity, and that's all you get, 9.8. Okay, let's just say. And you drop it from up here, and you get 19.6. So you increase it, you double the velocity. Okay, but you have to drop it 4 times the height to do that. To get the time, it has to, it's all about this time thing. And this slows the time down, doing this archy thing. All right, so I guess I'll erase this and we'll talk a little bit more about that. All right, back. So I've made a reasonably decent curvature to make the argument. So you're doing the experiment down here at the base. And obviously, here, you're doing 99% of what you're doing in terms of work is going sideways, and you're not doing much going up work, very little, 1% kind of at the very beginning. And as you go up this arc, the percentages change, and then around 43 degrees or some sort of number like that, it becomes 50-50. But, and then it changes in the opposite direction where you're doing 99% going this way and only 1% going that way. So the work you're doing against gravity changes dramatically as you go further out. So this first little bit is really easy distance. There's no resistance. With a pendulum, you're saying there's almost zero resistance. So you don't lose any velocity, as you're going here. And then, whatever, there, you start to do work. But you're not doing much work per a percentage of your distance. So it's like drawing the rise in gravity quite differently. You can sort of see it like this would be 90 degrees. And if you were obeying gravity, that is 1/4 of the distance, you'd be at 22 degrees. Okay, it would be the point where you'd be at half your velocity. But it ends up being 43 degrees, okay, because of this stretching of the amount of work to distance. So where gravity, you can draw these units basically as just 4 equal units of acceleration here because of the curved line. These lines become quite different in terms of the amount of work, in the sense that it's more like, this, and then this, and then this, and then that, that's getting progressively larger. So it's a different equation to figure out how much distance per how much work. So anyway, the fact is the little balls do go pretty far, okay, in the rebound. So you could argue, okay, that it looks like half, okay, but I'm still going to argue it can't be for this reason. So until he comes up with some explanation for, or some example of a Newton's cradle that doesn't conserve momentum, that is one where 100 comes in this side and 100 comes in this side and 200 doesn't come out. Till I see that example, this, again, what he's arguing happened can't possibly have happened. Not conserving the momentum, destroying it, making it disappear, is not possible in the Newton's cradle. All right, so I really shouldn't have to emphasize the point any more than that. So I was just wrong to say, I said to be half, it has to go all the way back to 3/4. Like somehow it has to go all the way back here. And obviously half the velocity is a tiny, I mean, it's a small amount of distance, right? Half the velocity in the traditional lineup is here when you're forcing it, when you're going against gravity, and when you're going with gravity, it's here. Okay, so I was just wrong to say they were both at this location. So anyway, so I think that probably is enough. So he just didn't bother with the part I emphasized in my email to him. I emphasized the point that you have to include this argument. If you're not going to include this argument, we don't really have anything to say, because clearly the result is 100 momentums comes out. And you have to explain where your free momentum disappeared to, and how if I reduplicate just the 3 mass hitting a 1 mass with a total of 200, that somehow I only get 100 out, because I won't. All right. And he just ignored that, of course. All right, so we'll jump through the video and such. So he does a better job than I did in some respects, in the sense that when I did his video, I hadn't figured out to calculate the velocities. So, you know, for my theory to be right, it has to be going, both objects leave at the same exact velocity. So when the first impact happens, they both leave at the same velocity, the 3 mass and the 1 mass. And 75% of the energy is in the 3 mass, obviously, because it's 3 times the mass, and 25% is in the smaller object. And so they leave at 1/4 the velocity, and his calculation is 1/2 the velocity, because obviously they're not considering momentum. They're not considering that 1/2 the velocity means they gave the 3 mass, 3 units of momentum. They only came in with 2 units of momentum, and they gave it 3 units of momentum. They gave it free momentum. Again, the very fact that I have to argue the free momentum theory does, to me, seem like, boy, these people really are terribly desperate. You have a theory that depends on creating free momentum as a possibility? Man. You really think that's going to work out in the end? All right. Anyway, so we'll play from about here. Of the energy is now moving. Okay, he's playing me stating my thing, which isn't very useful, and then he states some stuff.
And so
he has it written down here. I should have read what he wrote, right? 25 velocity, and they say 1/2 the velocity. So clearly that's all stated correctly, and then he does frame rates. Now the problem with the frame rates is there isn't enough of them. So he's using 1 frame. And how reliable that is, I have no idea. I don't think it's practical. Yeah.
Okay, here I'm going to make the measurements.
Okay, so he did this cleverly. I mean, he has another program behind this one, and so he puts his mouse in a mark, and then he gets rid of this program, so the other program shows, and then he can make a line in a drawing program. So that I'll concede is a clever way of doing it. Somewhere in here he does that.
It's moving, so here we have the collision. I think the best distance to measure is this one.
I don't know exactly why that would be the best. Why not do this last one, because it looks just as long. It looks like it hit pretty much on the end of a frame, but regardless, the balls aren't even round. So you can see this in the picture. It's not even round. I mean, it's got a big dimple in it. Especially going forward, this edge is really uneven. So, I mean, maybe I'll blow that up just to show that this probably isn't the place you should have done the frame from. But again, the velocity is constantly changing. So through the whole trip, it's changing. Now it's changing less right there. That's where it's almost changing none at all. But, I mean, it's really hard to do this because the velocity is changing through the whole trip. So this isn't that easy an experiment to do correctly. So you can see this isn't round anymore. It's got this glare mark that sticks way out. So not too good. Let's see where it puts the mouse. Let's see, I'll blow it up even more. I didn't bother doing all this the first time because I was certain I could defeat the argument based on the distance thing, but you really can't because, yeah, it doesn't have to go very far to be going half the speed. So I was way wrong to say it had to go back 3/4 of the distance.
Any contact between the balls. So the one mass ball is about here.
Alright, so we'll look at that in a close-up and see what we have. I'm not too confident that's a great idea, but whatever. Yeah, he's on the outer edge of that little glare blob that's leaking out, so he is taking the very pointer is right at that. So the mouse pointer is obviously not straight, which is, I don't know why mouses do that, frankly. It'd be nice if they were straight, but whatever.
So let's draw a line. Next frame, and now we are here.
Alright, well, oops, got away from me. So now we are, let's see where he says the word here. Okay, so that's where he stops. Let's see if we can see that. Oops, oh, I made a mistake there. That's not right. Anyway, yeah, so it looks a little short, frankly, but whatever. You know, he's cut a little bit off of the, you know, that they're not exactly in the same mark. He's not on the very edge of that anymore. He's inside a little, but whatever. So, in my opinion, he's cut it a little short, but whatever. So we'll jump ahead. So he makes he has a mark on the other program. Now I'm not too sure exactly how accurate all of that is either, how well these programs line up. So he's made 2 lines on the screen that you probably
this is
can't
our
see.
Initial velocity for the one mass ball.
Yeah, they're there, but you can't see them. Oops, that's the wrong thing moving. I want to move. Well, too late.
Then we have the collision.
Right, so, alright, so now we'll move to where he's measuring the little one. And I didn't think it was that far out. Yeah, that was pretty bad. Let's see, why was he that far out? And he's measuring from the back edge. So this is the velocity coming out. So what he's really proving is that it's still going pretty fast because this is the bottom of the circle. So it hasn't lost much velocity yet. So, yeah, that's to his disadvantage, frankly. Measuring further away would reduce the velocity. So the very fact that it's still going half the velocity, or in my opinion, 1/4 of the velocity, yeah, indicates. So anyway, so let's just get to the conclusion because, yes, the drawings indicate it's a clear, you know, it's whatever you want to call it, 2-to-1. Yeah, you can't really see that, but this is, where's the other line? I can't even see it on here. It should be visible. Oh, he's got this one. Yeah, so this one, I want to see this over here. Okay. So I have to get this to move. Why isn't it selecting? Damn it. Huh. Everything but the right one is selecting. Alright, it's over here. There. So this does look like a half of this. So anyway, little fudges here, right? You make this a tiny bit bigger, you make this a tiny bit smaller, then you end up with 1/4. You know, 4 of these will fit in there, you know, versus 50-50 now. So yes, it looks to his advantage, blah, blah, blah. But again, he didn't bother to include in this video any explanation regarding how you explain the disappearance of that free momentum. Once you've created it, you really do have an obligation to explain where it went. All right, so here's his marks in better resolution. Okay, so this is the velocity of the two objects. So he's got them going the same velocity, which is correct. But again, he could easily be distorting them the same amount, so doesn't mean too much. And again, this distance is the key distance. Is this one frame really good enough to establish the velocity of the ball going in? And I would say probably not. Anyway, all right, so we'll get to so he calculates it as 7.3 and 9.6, and so you couldn't get more halfy, in terms of his measurements. But again, those are his measurements. Whatever. So and then he divides them by 4. So divided by 4, it should be 1.83, and divided by 3, it should be 3.6, I think. Yeah, 6.5. So duh. All right. But again, so that's it. There's no evidence that this could possibly be correct, okay, in the sense that there's no reasoning or explanation provided for how, when they both come back together again, how 100, half the momentum just disappears. So you have to explain how a Newton's cradle can have a total of 200 momentum go into it and only 100 momentum come out. You have to show an example somewhere on Earth where that happens, where I put 99 in one side going this direction and I put 98 going in this direction, right? Or 199, and somehow only one little tiny bit of momentum comes out. They both dead stop and only a little tiny bit of momentum comes out. You're not going to show that experiment. It's not possible, blah, 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 blah. So, I knew when I brought this up as an experiment, when I found that video, this is going to be another one of those videos. There's just going to be a problem because there's no instrumentality applied to it. So all you have are these video frames, and I knew the frames just weren't good enough. So this was going to be a dirty piece of mud, and it turns out that way. But again, the argument that you have to conserve the momentum without doing your vector math. Vector math doesn't work in a Newton's cradle. So if you show me where vector math works in a Newton's cradle, where this cancels this, where two things come in and nothing comes out, fine. But until I see that, it's theoretically impossible what you're claiming. There's no theory to defend it. You haven't got any. And you deliberately evaded it, frankly. I mean, I could read my email, but I pointed it out clearly that your biggest burden is to explain what happened to the momentum you created. If you're going to claim there's free momentum there, extra momentum, you have to explain what happens to it. Where does it disappear to? Because gravity is going to give it back 100%. And you have to account for its existence, now that you've created it. All right. So enough of that. So I did make, like I said, I'm sorry about the sloppy first video. And but again, the beginning of it was right and the end of it was right. The little part in the middle wasn't too good. Okay. But look, the arc of the circle, I guess I should emphasize that, just since I'm here, is the real, it's just another place where you're just saying you have to do some extra work to calculate this part, because this really does mess up, distances. There's no, I think, maybe I'll read the comments. Mindless Marbles has a comment where he's basically saying you can just take the actual distances, as linear. That this arc of maybe 6 inches, this is like a 6-inch arc, that you could take linear measurements and it would be okay. And of course it's not. because again, this is free. Here is free. So this part is free. You don't even count this as work against gravity. You don't start working until you go further and further up the line. So the last little millimeter is as much work, okay, as this long hunk of distance. So you're going to have a very long hunk of distance that's going to be the same amount of work as a tiny little millimeter in the end, going up. This is more work, and it gets easier and easier when you're fighting it. So as you're going this way, you get the illusion of more distance, but you're not doing more work. And then as you start going up, you have the opposite illusion of a lot less distance and a lot more work. So your distance this way here is essentially all distance up. It's all work, and this is all leisure. Okay, so that should suffice as an argument for that video. So let me just see if there's any other stuff to mess with in terms of comments. He removed the response video from his channel, so I didn't remove it. All I did was delist it. What a fucking, some more, they just have to exaggerate and lie. So that's their credibility. Exaggerate and lie, exaggerate and lie. That guy is really pathetic. So it's pathetic if you make a mistake to take a video down. That's pathetic. Oh, okay. It was late. It was 12 at night. I wasn't going to make a new video last night, so I just delisted the video. Not a big deal. All right, and this is Mindless's comment that I did see yesterday. Analyzing initial speeds versus maximum angle by pendulum versus horizontal distance versus vertical distance all requires a bit of trigonometry to go through, but I am willing to write out the details if anyone wishes. Understanding where my small oscillation approximation comes from is kind of important here. So that's not what I read last night. So what he said last night was, I agree that that's fine, and the angle isn't a problem. That's what he said last night. He's actually used the word linear. Linear measurements aren't a problem, something like that. So maybe it's down here at the 10-hour mark. All right. So again, I mean, you can do all the analysis you want. What I need you to do, Mindless, is go out and find an example where the vector thing, where you cancel this direction against this direction, happens in a Newton's cradle. So if you can show me where 150 goes in and 50 goes in this side and only 100 comes out, then you have an argument. But until you can show me that, all of this is moot. Don't you? I mean, you won't concede that it's moot if you don't have a single other example of momentum disappearing. Oh, fuck. His 36-minute response to your analysis was hilarious. Just littered with misunderstanding. So, no, there was only the one misunderstands. No, just littered with misunderstands and refusal to accept reality. So again, you really want me to show you the email? I mean, do I have to do that? I mean, I pointed it out to him quite clearly. You have to account for the energy coming back. It's a closed system. The energy's still in the system. Now you have to explain how it disappears. If you're going to argue it appeared, you have to explain how it disappeared. Damn it. After listening through the video, it's no longer showing. He took it down, I think. Duh. So you should, anyway. He had a response already, and it took it down. Seems very strange. Yes, it's not the usual process, so fine, do your, whatever, okay? It's just, yeah, it had a mistake in it, so I took it down. That's the logical thing to do. Oh, yeah. Yeah, it does seem, so what you should be saying is, wow, it's kind of amazing, really. He's made thousands of videos, and he's only had to take 2 of them down. He's only had to delist 2 of them. All right, it's still showing up in my watch history upload 2 hours ago. I can still view it from my history, but not showing on his channel. Might be a YouTube glitch. So these are people going to argue physics and they don't know what delisting is. Okay. So anyway, mindless marble. So this is it. Okay. I did some calculations ahead of time knowing this would be a topic of concern. So I'm surprised that you don't think conservation of momentum would be a subject. But anyway, for small oscillations, oscillations, small height relative to pendulum height, I got. So we did this little formula thing. So x is indeed linearly proportional to v in this instance. And that's just plain wrong. I mean, so he made a mistake. So maybe he'll delist this comment. It's clearly not linear. I mean, it's clearly a curved surface. It's clearly insanely unlinear. And then it goes from 99, it goes from, 99% of your velocity is going this way and only 1% is going this way here. And here, 99% of your velocity is going sideways, up, and only 1% is going sideways. I mean, clearly not linear. Oh, damn. I have more complicated trig analyzing the relationship without any approximations, but they yield similar results. Hope this helps. I don't know exactly how it could possibly help, but whatever. If you want me to explain this or give more in-depth equations, feel free to ask. Well, I'm asking you to just show me somewhere on the internet, some video, let's just say. I don't care if it has to be somewhere on the internet, somewhere where Newton's cradle obeys vector math and subtracts this direction from this direction and gives you some chance of getting rid of that 200 momentum you created. You start with 100, you imagine you have 200, and then you end up with 100 out, and you're claiming that's real. You really do have to explain where it went. So I don't know why people do strange things. Why did the Leksa guy heart this? I mean, frankly, so x is indeed linearly proportional to v in this instance. It's just a completely insane. The shorter the pendulum, the more impossible that is to be true. Now, the pendulums on my porch, that have 88 inches, not 6 inches, 88 inches, that has some hope of being true. It's not absolutely true, but obviously you can go a pretty good distance before you do any work. But this, not a chance. All right. So typical, crap, from the commenters. It's just, the internet is just such a shitty place. All right, so maybe we'll go check out some other, see if there's anything else relevant, so I don't bother making 2 videos. So I'll concede sloppy error. Okay, I'm getting old. In the first video I made, but there's still, as stated, the initial argument that you're making free momentum, which is kind of silly, and the counter argument that Newton's cradles don't allow you to make that momentum go away. You can't use your little vector shenanigans to say this way subtracted from this way. So I'd subtract this 50 from this 150, and then I only end up with 100. Newton's cradles don't do that ever. So try again, because that crap ain't gonna fly. All right. So pause. Alright, I should be back. Alright, so physicist Michael did a video that was, it's another one of these completely uninteresting 500-year-old science. I don't know, it's just like putting a stick in mud, and the mud sticks to the stick, and, oh look, mud sticks to the stick. I mean, you could stick it in poo. But anyway, it's just, nobody's disputing any of this crap. I mean, certainly And I don't know to whose value this is. This, let's just contrive a fake formula. Garbage in, garbage out, right? So they put a square where there doesn't need to be one. You could take the square out and you'd get the right answer in the end anyway. Everything stays the same. It doesn't change anything. So if you want to get 9.8 meters per 1 second, you can get that. If you want to get 9.8 meters per second squared, you can get that. So it's just, it means nothing. All right. So this is their fun though, because they'll do math. So, the John Sean Walker. So this is the free energy nut. Let's understand. This might as well be a government conspiracy, UFO, free energy nut. And physicist Michael responds to him, which is funny, with another one of his veiled shit comments. Okay, for anyone else reading this. This is what it looks like to provide some criticism for an experiment. So there's no criticism of the experiment. There's just a simple argument about how, well, maybe your measurements are a little bit off because I got a little bit slightly different numbers. No criticism involved. Not just saying, I don't like your data conclusion. So it's another fucking one of his lies. Okay, I've explicitly explained what I don't like about your experiment. All right, he takes the same spring and creates two entirely different momentums out of the same spring. All right, I'm just simply arguing springs don't do that. And then what's the implication of your experiment? Well, the implication is that you go to infinitely nothing and infinitely something. There's nothing that ends it. Okay, he says all I have to do is keep putting heavier weights in front of the spring and I get more and more energy. I put lighter and lighter objects in front of the spring, I get less and less energy. Obviously completely different than a gun, right? Where all the energy goes into the light thing and the heavy thing doesn't get any energy at all. So those are real arguments, okay, saying there's a discontinuity. It doesn't fit the other experiments. It doesn't fit what the rest of the world is doing. So in one part of the universe you have rules, in another part, the gun, the rules are different. Why are the gun rules completely opposite of the spring rules? So there's a real argument there, you lying piece of shit. Okay, God, he's just such a fucking fibber. All right. So something must be wrong because you can't accept the results. Yeah, I can't accept them because they violate the rule you said you can't violate in your other video. The rule where the rules of the universe have to be consistent. And if they're not, you have to explain the inconsistency. Where did you do any of that? Where did you counter-argue anywhere? Oh, that's right, you didn't. You just ignored all the arguments, as you always do. Just as you, well, whatever. But instead, identifying specific potential sources of error. Yeah, I did that. I told you the 49-cent spring might be what's causing the results. The fact that your little carts your expensive carts have very cheap springs might be the source of the problem. Okay. And then doing the work to determine how much error would have been present to explain the data. So again, it's data. And then seeing if that amount of error is plausible given the experimental setup. So again, I'm supposed to figure it out for you? You don't have to do your experiments right. I have to do the work of pointing out where they're wrong. Oh, I see. Double standard. Anyway, I think it's very plausible that I could have been off by a centimeter in measuring those distances. So he's just talking about who cares? Frankly, he's not measuring anything unique, right? So instead of doing any of the experiments he should do, instead of making levers and catapults and all of this kind of stuff and doing interesting new experiments, he's just doing the same crap that was done 500 years ago. Too uninteresting. So White Henry says, oh, interesting. If the measured period is off by X%, the period squared will be off by 2X%. Errors compound like that. Having a 1% error in the period gives a 2.4% error when squared. Oh, wow. I mean, 2.4 still doesn't add up to much. 3.4 doesn't add up to much either. Who cares? None of these errors are relevant. He's measuring something, gravity, using something that's swinging 10 inches. It's not exactly going to be the best ruler in the world. So what's the point of this? Jesus. All right. So, Bass and Bass asked a pretty reasonable question. Can you maybe do a video on compound oscillators with uneven or even masses and explain how it works? Does it conserve momentum or does it conserve Ke? So this, White Henry shows his stupidity here. I guess you could just argue. I read a little bit of this. Even a simple pendulum doesn't conserve momentum. So this idiot's going to argue because it stops and then moves back. Because something goes up and then something comes down in gravity, gravity doesn't conserve momentum. You don't conserve energy by throwing something up in gravity. You bang something into a spring, you're not conserving the energy, whether it's kinetic energy or momentum, because it stopped and then it started again. It's just idiotic. You're talking about the system. Of course, the system has to conserve the momentum. So it's such a stupid thing to say. Even a simple pendulum doesn't conserve momentum. Of course it does. It stops swinging because it's going up in gravity. Gravity's taking the energy, and then gravity's going to give it all back again. That's the absolute fact. It alternates between going to the left, stopping, and going to the right, stopping, etc. So this is just such crap. So the same is true for the kinetic energy then. Nothing's conserved. No one would say that. So this is the kind of word garbage they use, this playing with semantics and bullshit word games. Each time it stops has zero momentum. So again, more crap. It has zero kinetic energy too. So what? We know it's getting it all back. Each time it reverses direction, it reverses its momentum. Who cares? Oh, this is clearly not conserving momentum. Oh, it clearly is. In every physics conversation I've ever seen by a lecturer in physics, that's the definition of conservation, is you put the energy into some other device, and then the device gives it all back, whether it's a spring or gravity or a hydraulic system or air pressure. You're just storing the energy. A battery. It also doesn't conserve Ke, so this is just word games. It goes from having 0 Ke each time to stopping and having positive Ke and moving out. So everybody is always talking about the system's obligation to conserve the momentum. The momentum's in the system. It's in the car moving. You have to account for where it goes. This is the Feynman block argument. Feynman certainly wouldn't agree with this shit talk. All right, net momentum is conserved. So he's playing the game with this word net now. Oh, we all have to say net momentum because you're too stupid? Well, yes, you are, frankly. Because apparently you have to say 1, okay, square, when 1 second when you're doing 9.8. You have to say the 1 because you people don't put it there where it belongs. Net momentum is conserved, but that involves looking at the whole system. Of course, including the planet. Well, this is just the idiotic part. The planet's not doing anything. Okay, and the pivot, it is anchored to. So this is all just a more distraction. The planet's not doing anything. The ball bearing bouncing on the anvil is proving the planet doesn't do anything. The planet isn't absorbing 50 or 60 times the momentum. Bullshit. You're not going to be able to measure the changes in momentum of the planet. So again, just a lie that there's any momentum in the planet. Okay, just nonsense. It has zero evidence that there's any energy in the planet. All right, total energy is also conserved. Net total. What games are you playing? But this involves summing all the energies, not just Ke. There is no gravitational potential energy, so again, it's more nonsense. Losses to heat. Well, that's a real thing. You can measure heat. Kinetic energy losses to the movement of the surrounding air, and so on. Yes, well, air resistance and heat are all things we all know about already. And in these experiments, there's very little of them. We can assume the losses to heat and air resistance are minimal. There you go. So why talk about them? And get reasonably good results just considering Ke and Pe. Yeah, well, you don't have to consider Ke because it's made out of Pe. Duh. Oh, you're just such a jackass. All right. DS refuses to accept that momentum isn't conserved in the pendulum. Yes, net momentum, total momentum is in fact conserved, you fucking word puke game player. And you won't show otherwise. Show me your link, you piece of shit. Oh, God, these people are just so disgusting. I think he thinks that the Earth is too big to have its momentum changed by forces on the pivot point. Yeah, I think the fact is that there's absolutely no evidence of that. That when something's immovable, it is in fact immovable, in the sense that it's just too heavy. The energy can't get into it and you get a perfect reflection. That's what the evidence dramatically shows, that if an object moves, if I bounce a tennis ball off a wall and the wall doesn't move, I can get most of my energy back. If the wall moves, I don't get anything. I get hardly anything back. The more the wall moves, the less the ball bounces back. Do you accept that simple truth, you retard? Oh, disgusting jerk. But think about it. Where is the momentum in the instant in time when the pendulum is changing a direction at the end of this? It's in the compressed goddamn spring, you retard. Whatever is absorbing the energy. So obviously, they're called elastic. Okay, you throw something against something, it's called elastic. That means the energy does go in, but it comes back out again. It's reflected. Now you can see that in a tennis ball. Now you don't see it in two metal things hitting each other, but the fact is it's happening. There's vibrations going through the metal, and those vibrations hit the wall and bounce back. They physically bounce back. They physically do it. If I take two steel balls and smash them into each other and don't allow them to bounce, all right, and put a piece of paper between them, I'll burn the paper, because they're going to continue to push the energy back out. They're going to keep reflecting it. And you'll even see rings. The burns will make rings, showing you the fact that it's vibrating. Dumbass. Okay. All right. Where's the momentum in the instant of time when the pendulum is changing direction at the end of the swing? Well, that's gravity. So everybody understands how gravity works. You go up in gravity, then you fall down out of gravity. That's what happens. It's too simple. It is stopped, so there's no momentum in the bob. Again, it's because it's in your gravitational. You've gone upstream. You have rapids. You're going to go through the rapids. You go down a ski slope, and then you walk back up, and you go down the ski slope, then you walk back up, and then you go down the... Yeah, not complicated. Where has it gone? It hasn't gone anywhere. It got used up. It ran out of energy. It's a simple truth. You ran out of gravity. You ran out of ground. You ran out of air to free fall in. Okay, you hit the ground. Well, now you have to go back and find some air to fall in again. We know momentum is always conserved, and we can see that the string and the bob are instantaneously motionless. So why does he say we know momentum is always conserved? Why are you saying that when you just said it's not? You have to say total momentum, or you have to say net momentum. You have to obey your own semantic rules. You just violated your own rules of proper wordage. Oh, you're just such a piece of shit. And we can see that the string and the bob are instantaneously motionless. Where is the momentum? It's in the system. You've created a system where you've created more air for the thing to fall into. Okay, more free fall distance. So yes, it will free fall. And you have to do work to gain air. You have to climb up the mountain to go down the slope. Oh, Jesus, he's so stupid. All right, the curve fit G to within... So again, he hearts these bullshit comments. If the errors were random in different directions, I understand that the curve would fit the average. So again, this is just all who could care about these minutia little errors in an experiment clearly not exact enough to get perfect numbers. And who cares? Again, it's measuring something everybody already knows. So then the Dark Endless says, can you please respond to DraftScience 5-minute videos? It's not only him that wants to see a response out of you. Well, he doesn't care what you want. And then Farley, the troll, just does a bunch of poetry. So, you know. Anyway, so that's where we are. So we're still waiting on the lever thing. I'm going to do another catapult experiment eventually if the wind stops blowing. And, I just really can't clear enough space down here to do it indoors. Yeah, so we're just, stuck until, again, it's the argument's simple enough. I've challenged them to show me their evidence, and they don't have any. So all they have is the cart experiment. All they have is banging the one mass cart into the two mass cart and creating this extra momentum, the free momentum experiment. That's all they have. In 350 years, that's the only kinetic energy experiment they can show you. Because if they show you the Brozo clay thing, again, I've already debunked that in one of those 5-minute videos. I've already demonstrated that denting clay with round things isn't going to work. And I can't get this, this person to concede. So this is a critical experiment in the history of kinetic energy, the clay experiment. And he won't comment on it, he won't respond to it, he won't say anything, he's moot. Okay. Critical experiment, and it was a complete fraud. That is, it was an illusion. It wasn't really testing how much energy the objects had. Because they didn't understand the system's dynamics, that it's not a linear measurement, and it won't give you an accurate answer. Just like rolling a ball on a surface won't tell you the distance it travels, won't be telling you how hot the ground got. It won't tell you how much work it did. You have to understand, that it's not linear, to use the scientific terminology. All right. So that's probably all there is, but let me just go look and see if there's some other piece of crap to respond to. Alright, so I guess that'll have to do, pig. Till the next time and such and so forth and whatnot. This has been a draftphysics.com video presentation going over the same crap over and over and over because nobody will grow enough of a ball to respond to the dozen or so videos, 5-minute videos I have produced, pretty much pointing out how it's illogical, frankly, and unreasonable to argue in defense of 1/2 mv squared as being anything but a fable and such.